Hi, we're going to do part 2 of simple covalent, and this will encompass the more common examples such as water, carbon dioxide, and ammonia gas. So let's get moving. So this three are the very common examples. So we're going to get started. So the first thing here is be able to write down the formula of water, which is H2O. So if you are looking at the periodic table, you will see that hydrogen only have one electron. That means its electronic configuration is going to be just one. Okay, so the rule here is need one, share one. Okay, and why is it in the hydrogen case it only need one? Because, there's only one shell, right? And the first shell can hold a maximum of 2 electrons, so it just need one more to become stable. In the case of oxygen, 8 electrons arranged in this 2-6 configuration, so it needs 2 more, willing to share 2 electrons. So how we draw this is we'll put oxygen in the middle and we'll put hydrogen on the side. Okay, there are 2 of them. If you look at the formula, it's H2O. So I'm going to zoom in a little bit. Okay, so for oxygen, or rather, I'm just going to start with hydrogen first because it's easier. Hydrogen, each of them is willing to share is one and only electron. So I'm going to put an X inside. Okay, as you can see, I'm not sure why the dot is here. Okay, it's gone. And then for oxygen, I'm going to use circle. Okay, so it's willing to share 2 electrons. That means because there are 2 sharing space, I'm just going to highlight in green, 2 sharing space. Each sharing space will have 1 electron of oxygen. Okay, and so start off with 6, share 2, so 6 minus 2, you end up with 4 electrons that is unshared. So this 4 electrons that is not shared cannot go into the green sharing zone area, so it needs to be on the outside. 1, 2, 3, 4. So there you have it. You have water. And you can do a quick check in terms of counting. So you have 1, 2, 3, 4 electrons for oxygen, and you have 5, 6, 7, 8 after its share. And every hydrogen, if you take a look at it, has 2 electrons in its shell after sharing. So it is stable. All right, next one. Ammonia gas. Ammonia gas has a formula of NH3. Nitrogen have 7 electrons altogether. So the electronic configuration is 2, 5. That means it needs 3 more electrons to be stable. So it's willing to share 3 electrons. H, same thing, only 1 electron. So need to share 1. Okay, all right, so let's go. We will draw nitrogen in the middle. And I should use the other color, isn't it? Okay, nitrogen in the middle and 3 hydrogen. Okay, so each hydrogen is willing to share that 1 electron that it has. 1, 2, 3. Again, I'm just going to highlight the sharing spaces. That's where all the sharing of electron will take place in this green color zone. And nitrogen, out of its 5, it is willing to share 3. So I'm going to use crosses. So because there are 3 sharing zones, so each sharing zone get 1 electron of nitrogen. So 5 minus 3 that's being shared, we actually have 2 electrons that is unshared. So these 2 electrons needs to be part of nitrogen, but not in the sharing space. So it just be like this. If you do a quick count, 1, 2, 3, 4, 5, 6, 7, 8. So that's how it becomes stable. Okay, finally, carbon dioxide. Carbon dioxide has a formula of CO2. Okay, carbon, 6 electron arranged in 2, 4 configuration. Wow, 4. This is the first time you see the 4, isn't it? Okay, so with 4, it needs actually 4 more electron to be stable. So it's willing to share 4 electrons. In the case of oxygen, it will have 8 electrons. You need to refer to the periodic table to understand why there's 8 electrons, okay? So it's 2, 6. So it's willing to, it needs 2 more to be stable, so share 2 electrons. So how this works is we only have 1 carbon, so carbon in the middle, and 2 oxygen on the side. Okay, so let's take a look at carbon first, okay? Carbon has 4 electrons on the outside. It needs to share all 4 of them. So if you look at the sharing zone, we only have 2 sharing zones. And carbon wants to share all 4. So 4 divided by 2 means each sharing zone would get 2 electron of carbon. Okay, and then we look at the oxygen. Oxygen out of the 6 is willing to share 2. So I'm going to look at oxygen number 1 first. For oxygen number 1, I'll put 2. Then you will see that the total of 6 minus 2, that means 4 is unshared. So oxygen number 1 will have 4 electrons surrounding it. And oxygen number 2 will do the same thing. So 2 in the sharing zone, because it's willing to share 2, and then the other 2 will be on the outside. Okay, so this is how we get carbon dioxide. So hopefully with this, you are able to see that it is stable. All good.